Hello and welcome to my channel. In this video we will learn graphical method to solve linear programming problem. Okay, so graphical method to solve linear programming problem. Okay, so first of all we will consider a linear programming problem. So consider the following. Linear programming problem. So maximize z equal to 250x plus 75y such that we have the constraints, that as the linear constraints as 5x plus y less than or equal to 100, x plus y less than or equal to 60, and x y are greater than or equal to 0. Okay, so what we have to first do is we have to consider the constraints, and if we consider the first constraint, you have to then further write the line corresponding to the first constraint. Okay, so line 1 will be 5x plus y equal to 100. Okay, this is a linear inequality, so if you want to write the line, so less than equal to it will be converted to equal to. So 5x plus y equal to 100. Okay, so let us make the table for x y. So y is nothing but 100 minus 5x, right? So if x is 0, y will be 100. If x is 20, then y will be 0, right? 100 minus 5 times 20, that is 100 minus 100, which is 0. Then if x is 10, so we will get 50 here for y. Okay, so this is the table. Now let us consider the line 2. So line 2 will be the line corresponding to the second inequality. So x plus y equal to 60 we will get. X plus y equal to 60, right? So x and y is what? It is 60 minus x, right? So x is 0, that means y will be 60. If x is 60, y will be 0. Then if x is 30, y will be also 30, right? So this is the line 2. And this is the table for line 2. Now line 3. So we have to consider the third inequality, so that is x greater than or equal to 0, and corresponding to that x equal to 0 is the line, right? And line 4 will be, so we have to consider the fourth inequality, y greater than or equal to 0, and the corresponding line will be y equal to 0. Okay, so now what we have to do is draw the graph here. So suppose this is the y axis, this is the x axis, right? So this is y axis here, this is the origin, this is the x axis, right? And then now we will draw the points here. So 10, then 20, right? 30, 40, 50, 60, 70, 80, 90 and 100 here. Okay, so similarly here 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So let us consider the line 1 here. So when x is 0, y is 100, right? So the point will be here. Okay, when x is 20, y is 0, so the point will be here, right? And when x is 10, y is 50, so like this here. Okay, so 3 points. What we have to do is join the points by a line here like this. Okay, so this is the first line we have, and we will name it. So it is 5x plus y equal to 100. So 5x plus y equal to 100. Okay, now let us draw the line 2. So when x is 0, y is 60. When x is 0, y is 60. Okay, here when x is 60, y is 0. When x is 60, y is 0, and when x is 30, y is 30. So the point will be here. So again we will join the 3 points with a line. Okay, and let us name this. So this line is x plus y equal to 60. Then this x equal to 0 is the line y axis right here, and y equal to 0 is the x axis. Okay, now we have to find the solution region for each inequality, right? So what we have to do is put 0, 0 in the first inequality. So put 0, 0 in the inequality 5x plus y less than or equal to 100, right? So that is what we will get is 5 times 0, because we have to put 0, 0 in this. So 5 times 0, x is 0 plus y is also 0 less than or equal to 100, right? So that is we will get 0 is less than or equal to 100, which is true. So therefore the inequality is satisfied, right? The inequality is satisfied. So what we have is, therefore the solution region is the solution region is the half plane where 0, 0 lies. Okay, so the solution region, if we mark it here, we are considering this line right here. So the solution region will be in this way. Okay, like this. Why? Because you can see that the 0, 0 point lies in this half plane. Okay, so the solution region will be this. Okay, now again we have to put 0, 0 in the second inequality. So put 0, 0 in the inequality x plus y less than or equal to 60. Okay, that is 0 plus 0 is less than or equal to 60. That is 0 is less than or equal to 60, right? So therefore the inequality is satisfied, and so therefore the solution region is the half plane where 0, 0 lies. Okay, so the solution region is on this side of the green line. Okay, so in this way. Okay, now we have to consider the third line, which is x equal to 0. Now we cannot put 0, 0 in the inequality because x equal to 0 passes through the origin. Okay, so we have to put some other point. So put 10, 10. Let us put 10, 10 in x greater than or equal to 0, right? So that is 10, because x is 10 greater than or equal to 0. So therefore the inequality is satisfied, right? The inequality is satisfied. Therefore the solution region is the half plane where 10, 10 lies. Okay, so where is 10, 10? So x equal to 0 is the y axis here, right? So 10, 10 is here, right? So that means the solution region will be like this. Okay, here is the solution region. Okay, now similarly we have to put again 10, 10 in the fourth inequality. So put 10, 10 in y greater than or equal to 0. Okay, so that is 10 is greater than or equal to 0, right? So therefore the inequality is satisfied. Okay, so therefore the solution region is the half plane where 10, 10 lies. Okay, so y equal to 0 is this line, x axis. 10, 10 is above that. So the solution region will be this. like this. Now you can see that the intersection of the all the regions is what is this. Okay, here. So we call it as the feasible region. Okay, so the feasible region is the region obtained by intersection of all the solution regions. Okay, and that is, in this case, if we call this as okay, this is origin, then this is A here, right? Point A, if we call this is point B, this is point C, right? So the solution region will be O, A, B, C, O. Okay. Okay, now let us find the values for Z at the corner points. Okay, so now you have to understand that this region is a bounded region here. Okay, so whenever the feasible region is bounded, the maximum or minimum of the function Z occurs at the corner points. Okay, so since the feasible region is bounded, the maximum or minimum of Z occurs at the corner points. So at each corner points we have to find the value of Z. So that means at origin, which is 0, 0, what will be Z? So Z will be, see, Z function is this here, 250x plus 75y. So that means 250 times 0 plus 75 times 0, which is 0, right? Then at next point, that is A, so that is what, this 20, 0. So 20, 0, Z will be equal to 250 times 20 plus 75 times 0, which will be equal to 5000. Okay, then at B, so if you want to find this point B, we have to take the intersection of these two lines and find the point B. Okay, so for that, let us take the line equations of both the lines. So 5x plus y equal to 100, and then x plus y equal to 60. So if we minus this both, that means we will get 4x plus y minus y will get cancelled, equal to 100 minus 60 is 40. So that means x is equal to 10, right? Now we will substitute this x in the second equation. So what we will get, 10 plus y equal to 60. So that means y is equal to 50, right? Okay, so B will be what? So point B actually, B is x is 10 comma y is 50. So B is 10 comma 50. So Z will be what? 250 times 10 plus 75 times 50. So that is nothing but 2500 plus, so let us find out 75 times 50. So 05 times 5 is 25, 5 times 7 is 35, 35 plus 2 is 37. So 3750. Okay, so if we add 3750 and 2500, we will get 0, 5 plus 0 is 5, 7 plus 5 is 12, 3 plus 1 is 4, 4 plus 2 is 6. So 6250. Okay. Okay, now at last point we will find the value of Z. So C is what? This is 0 comma 60. So at 0 comma 60, Z is equal to 250 times 0 plus 75 times 60. So 75 times 60, if we do 0 and 30, right? 6 5 is 30, 6 7 are 42, 42 plus 3 is 45. So it is equal to 4500. So what we get is, therefore, which is the maximum value between 0, 5000, 6250 and 4500? It is this, right? 6250. So therefore maximum Z is equal to 6250 at the point B, which is 10 comma 50. Okay, so this is how you have to solve the problem. Now in this case, for this problem, the solution, the feasible region was bounded. Okay, so the maximum or minimum occurs at the corner points. Now we have to take the case that if suppose the solution region is not bounded. Okay, so if the feasible region is unbounded. Okay, so this case you have to consider. So now let us draw a graph to understand what you mean by unbounded. Okay, so this is the x-axis, this is the y-axis, origin here. So if the lines will be in this way, okay, yeah, so if the lines are in this way here, so you can see that the two lines are intersecting, and if the solution region is like this here, the feasible region, I mean, okay, so you can see that this region is unbounded. Now in this case, what we have to do? So we have to do the following thing. So first let us consider the Z function. So let Z be equal to ax plus by be the objective function. okay, and let the feasible region be unbounded. Okay, so if capital M is the maximum value of Z at the corner points, okay, if M is the maximum value of Z at the corner points, then M is the maximum value of the problem, okay, if there is no common point between this inequality ax plus by greater than m and the feasible region. Okay, so have you understood? If m is the maximum value of z at the corner points, okay, if you take these corner points and if you find the value of z and if you find that m is the maximum value, then m is the maximum value of the problem, okay, if there is no common point between this inequality and the feasible region, okay, otherwise, okay, so that means if there is a common point between this inequality and the feasible region, then the problem doesn't have maximum values, okay, otherwise the problem does not have, the problem is z, okay, does not have maximum value. Maximum value, okay. Now second, now if small m is the minimum value of z at the corner points, okay, and then small m is the minimum value of the problem if there is no common point, there is no common point between this inequality ax plus by less than m, okay, and the feasible region, and the feasible region, okay. So suppose there is no common point between this inequality and the feasible region, that means the minimum value of z at the corner point is the actual minimum value of the problem, okay, otherwise there is no minimum value of the problem, okay. Alright, so that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.